Well, good afternoon, everyone. So I'm here today to talk to you guys about Microsoft's modern data warehouse architecture. And we'll kind of go into a little bit what I mean by that. But in general, our agenda today is we're going to start off by talking about kind of the traditional model for data warehousing, talk about what some of those drivers are for a more modern solution, and then we'll go through what we mean by that more modern solution. We will be doing a little bit of a demo around specifically Azure Synapse. And again, we'll talk about what that is. And we'll close out with a little bit around how there's some lifecycle differences from a development lifecycle perspective with a modern data warehouse versus more of a traditional model. Just a level set, however, this is not a particularly technical conversation. This is more of an introduction to kind of set the landscape of what a modern data warehouse is. We're going to go through those kind of concepts and not necessarily do a deep dive on any of the individual components. However, I mean, if there's interest, I'm more than happy to come back at some later month and do more of a deep dive of any of the components that we talk about here today. But again, this is meant to be somewhat high level. Obviously, it is a technical conversation, and I do expect that there's some level of understanding around data warehousing concepts. But again, when we get to then, feel free to ask questions if anything is not clear. So we sort of start off with this kind of traditional data warehouse concept. You know, and data warehouses have been with us for over 30 years at this point. They're tried and true, and they not only have worked for us, they continue to work very well for a large variety of situations. This diagram that I have up here on the screen, it kind of represents maybe a little more of a mature traditional data warehouse model where we have incoming data coming from normally some sort of transactional operational system, goes through a traditional ETL process and ends up landing into some sort of storage repository. And again, in this diagram, we have an enterprise data warehouse, we have a metadata repository, and we also have an operational data store. And we're not necessarily going to go through any of the differences on there, but that ends up becoming our kind of storage medium, where it ultimately then lands in some form of data mart. In, Microsoft's world, that might be analysis services, could be something like Power BI, or it could be any number of third parties, but that's typically how the output side of it works. The things to understand here, though, is that this model tends to be fairly rigid. It also tends to be fairly tightly coupled together. It's kind of monolithic in nature. It's fairly difficult to pull out any individual component of this and swap it out with something else. Again, due to kind of this tight coupling. And that results in projects that tend to be massive, at the very least span many, many months, oftentimes spanning multiple years to develop something that is a mature data warehouse platform. But again, this model has worked and continues to work for many organizations, and it's not necessarily going away anytime soon. The purpose, though, of this slide is just kind of to set the stage so we can use it as a bit of a contrast as we go into more of a modern model. So why are we even talking about a modern model? What are some of the drivers that are pushing organizations to it? Well, there's three main drivers, and they're listed here on the screen. We have agility, this move to the cloud, and then ultimately a desire to get towards a return on investment quicker. When we're talking about agility here, it's important to understand that we're not talking about an agile development methodology. We're really just talking about, the base word agility. We need to be able to react quickly to our changing business needs, be able to spin some of these things up in a rapid manner and adopt and maybe even take away some of these elements as our environment matures and our analytic needs change over time. So that's kind of the three little bullets here. Right? We want to be able to react quickly to those business needs. We need to be able to ingest data from a wide variety of sources. So contrasting to that previous diagram we had, most of those type of sources are coming from those, what we'd consider to be kind of traditional data sets. So a transactional system, maybe an ERP, a CRM system, that sort of thing. But in today's world, we're pulling data from everywhere. It could be third parties, it could be web services, it could be IoT data that's flowing in real time. So we need to be able to ingest it quickly. And we need the ability to be able to experiment against that data, again, quickly and ultimately cheaply. So that is some of the kind of drivers that's pushing this. But the bottom line usually comes down to the bottom line, that return on investment. A lot of organizations are just no longer willing to let a development team disappear for 18 months while they develop a new data warehouse or alter an existing data warehouse to take advantage of new business changes. They need to have that ROI realized sooner. And so that is another big driver for this. So what are some of the characteristics, the modern characteristics of this data warehouse that facilitate this? One, a modern data warehouse tends to be modular. And we'll talk about this quite a bit when we get into some of the examples. But we have the ability to plug in components as needed. So you don't have an IoT need today, for example. Well, we don't then develop an IoT real-time pipeline in our data warehouse. But we have a data warehouse that is modular enough that we can plug that in later when it does become a need. It's also this idea of modular is around being able to grow organically with a business. And I think this is a pretty important distinction as well. A traditional data warehouse tends to be an area where you have to be a pretty big organization to play. There's just so many moving parts, so much expertise that you need to be successful with a data warehouse that it's really hard to start that when you're small. Where this kind of a modern concept around a data warehouse, we can start extremely small and start building that up as the business grows. We're also trying to reduce some of the vendor lock-in. This has been a big problem for a number of years. Is you get locked into, let's say, Microsoft's ecosystem or Oracle's or Teradata or whoever it happens to be. And now we're kind of paying that tax forever. And it's a constant upgrade cycle and so forth that we kind of get locked into. And so we continue to pay for these solutions over and over and over again. The next major characteristic is this concept of being elastic. So what we mean by elastic here is this ability to scale up, but also scale back down and to scale in and out. And so what I mean by that scaling up, so it's increase the compute resources behind it when we have greater demand, and then be able to tear that back down when we don't have that demand. And on the in and out side, this is more of a scale up scenario where we have multiple instances of, let's say, our data warehouse or whatever component, this modular component that we're talking about. Most of these modern systems also allow us to pause these services. A good example of that might be your ETL process. If you're in that traditional mode where you're just doing batches nightly, most of the time that ETL system is sitting there largely unused.
Right.
So you have a scenario where in an on-premise scenario, you are paying for that 24 hours a day for that server to sit there and be idle when it might only be working a few hours every day. We can pause those type of services in the cloud side of this and then only pay for the usage that we actually have. And the last one here is this fluidity. This is what we kind of talked about in the previous slide, but it is that any type of data at virtually any rate and any size. So when we get into some of these components, something like Azure Data Lake, we have the ability to handle petabytes of data, not just things measured in terabytes or smaller. And so you can get to some truly massive data sets and still be able to query across it. So another concept here that is important to understand is from a base component perspective, most of these services that we're going to talk about today fall into one of these categories. They're either a storage service or they're a compute service. And this is probably a little bit foreign if you are just used to working with on-prem environments, because we tend to blur these lines in on-prem. When we think of a SQL server, we typically think of the SQL server in a holistic view. It is our storage engine and it is our compute or query engine. We don't typically separate those things. We might a little bit when we're talking about maybe tuning some of the storage. We might be tuning a SAN or some sort of underlying storage
That makes
subsystem, but we
sense.
don't typically think of them as distinct and separate components. When we're talking about these cloud services, oftentimes we have a very, very definitive line between these services. In fact, this is what allows some of that elastic nature. So if you take something like Azure Synapse, or what used to be called Azure SQL Data Warehouse, the compute side of it is separated from the storage side. So that's what allows us to pause the compute, because the storage side stays resident and it doesn't go away. And so we can increase that compute, we can shrink that compute, we can stop the compute altogether and not lose any of the fidelity of our underlying data. And so from this perspective, from a component perspective, it is important to always think of this into these kind of two bifurcated areas: storage and compute. So let's get into some of the Microsoft services. These are the ones that we'll be primarily talking about today in this discussion. But we have Azure Synapse Analytics, Azure Data Lake. Power BI is part of this. It's not technically an Azure service, but it definitely plays into this kind of cloud modern data warehouse model. We have Azure Data Factory, Databricks, and analysis services. And then there's an entire pool of miscellaneous services that will work with this, but are not necessarily a first party into this kind of modern data warehouse model. They're a little more optional. So first, Azure Synapse Analytics. Already mentioned that this is sort of the rename of SQL Data Warehouse in Azure. At least that's where it started. So last fall, when Synapse was announced, the very first version, the non-private preview version of it, was just a rebranding of Azure SQL Data Warehouse. It's quite a bit more today, but when we talk about it from our perspective in a modern data warehouse, what we're really talking about is the workspace aspect of that. And we'll get into a demo of this so we can explain it a little better. But essentially, it's this ability to have a single pane interface, a single portal, basically, that allows us to manage all of these little spoke components of our data warehouse hub that we're having here. So we have things like our Azure Data Lake, Data Factory, SQL pools. That's the SQL pool is the name that's assigned to a data warehouse instance in a Synapse world. We have Spark pools. Again, it's a Apache Spark on-demand type of service. The SQL on-demand, we'll do a little demo around this too. This is something that's new. If you're at all familiar with what Microsoft's been working on for probably the last 2 years, it used to be called Project Starlight. This is a serverless query environment on top of Azure, so we can use it to query assets such as our data lake or a storage account inside of Azure. So we'll do a demo of that. And of course, we have Power BI that's tied into this, Azure Analysis Services, and then there's some other miscellaneous like Azure Event Hub, where we can do some event-driven data warehouse type of activities. This, though, is kind of our hub, as I pointed out. It's that single pane of how we look at this. The Azure Synapse workspace is something that brings us all together regardless of what component we're using. We can use a workspace and not have a formal SQL data warehouse component as an example, or a formal SQL pool. We could use some alternatives there instead of the product or the service that's called SQL Data Warehouse, or was called SQL Data Warehouse. So while it kind of shares a name here, that Synapse Analytics, just understand that from when I'm talking about this, it is really more about this portal experience and single kind of development pane than it is the actual data warehouse side of it from a compute and storage component. But we'll, again, get into a little more detail out here in a few moments. Our next side of this is Azure Data Lake. And if you're not familiar with Azure Data Lake, When I'm talking about Azure Data Lake today, I'm specifically talking about Azure Data Lake Storage Gen 2. So it's the second generation of Microsoft's Data Lake product. Their first Data Lake was a very proprietary system inside of Azure that was separated from all of their other storage mediums. Generation 2 of Data Lake uses Azure's blob storage mechanism, a standard storage account, but it enables a hierarchical file system versus more of an object store, which is what typically blob store is. And again, if you guys have questions at the end about that, I can go into more detail. The detail right now isn't so important. What is important, though, is this acts as our central storage platform in Microsoft's modern data warehouse vision. And why that's the case is every single Azure component and most third-party components are able to interface directly with an Azure storage account. So we can read and write data to the central spot, regardless of what it is. So I have an IoT hub, I can write here. I have Stream Analytics, I can write here. I have Azure ML, I can write here. It's a universal supported component. It's also a universal component from an Azure data center perspective. Every data center in Azure's world gets deployed with a storage system, meaning Azure storage, and along with that then comes Data Lake. And so it's again, kind of a universal. Everywhere that you find Azure, you're going to find a Data Lake component to it. And that's what brings it as our central storage platform. It may not be your final storage platform. We may still be pulling this into a relational database or maybe a Spark cluster or something along those lines. But it is where the data would land, at least initially, in this type of a model. So things to know about it: it is low cost, massive scale, it's high performance, it's Hadoop compatible. That's another important point, because I can take something like an off-the-shelf application that supports Hadoop and connect it to a data lake as though it's connected to Hadoop. It's an emulation layer, but from its perspective, it doesn't know that it's not speaking to a Hadoop file system. So it allows a lot of compatibility here with other tools. Next is Power BI. Hopefully everyone knows what Power BI is at this point. It's the #1 data visualization platform in the world. It continues to grow at a very, very rapid pace, and it integrates with a very wide number of sources out there, and it is starting to integrate more and more with this kind of modern platform. The primary way that we would use it in this platform is through its integration with Data Lake and its Power BI data flows, which use a common data model. Again, if you want more information about that, let me know when we get into the question and answer, and we can dig into that a little more. But this is Power BI's ETL engine will use Data Lake as a storage medium, which then, again, once you do that, that opens up the door to be able to integrate with any number of these other services, not just Power BI. But it's an important spoke here in this kind of hub that we're talking about. So Data Factory is our next component. You can kind of think of Data Factory as SSIS in a cloud. It is quite a bit different. It's mostly different in just how it's structured from a scalability and its serverless kind of nature. And at its base, Data Factory is really only the workflow or the orchestration engine side of SSIS. It isn't
Taking a
the
look
data
at
flow side of SSIS.
Pierre, we lost you there for a little bit.
Am I back? Can you hear me?
Yep, you're back now. About the last 10 seconds, we lost you.
All right, sorry. So where I was at is I was trying to explain kind of the difference between this control flow methodology, which is that orchestration engine in SSIS, and the data flow side of SSIS. So Data Factory is primarily that orchestration side, that control flow. It is what kicks off all of those kind of sub-processes that are actually doing the ETL on your data. And it can utilize a number of different compute engines to do that, such as Databricks, such as Spark or a SQL Server instance and a number of different things. But from our perspective, again, as we're painting this picture of architecture, it's kind of the glue that connects all of these services. It orchestrates our data movements. Next, we have Azure Databricks. This is not a Microsoft product specifically. Databricks is a third-party component, but it is built in as a first-class citizen inside of Azure. It's also built into AWS as a first-class citizen, but it is a wrapper for Apache Spark. Essentially, it's an automatic cluster management system for Spark, and it has some extra features too, specifically this last line here, which is called Databricks Delta Lake. It brings ACID transactions to Spark so that it isn't just a write once type of system. We can actually do some updates and that sort of thing. It is an important part, especially on the integration portion of a modern data warehouse. And next, Azure Analysis Services. This is a fully managed tabular model, so we don't have yet, and maybe never, multi-dimensional models in an Azure Analysis Services, so this is tabular models. The main difference here, when we're kind of contrasting with this with something like Power BI, is Power BI is essentially the same engine under the hood. But one, Power BI tends to get the features quicker and sooner than what you'd get with Azure Analysis Services. And it's a little more managed. We don't have the ability to build out some of the scalability and elastic nature like we do in the Azure Analysis Services component. And so that still plays a role here depending on what your kind of model is. But it is our semantic layer. This is the layer that is ultimately feeding up the data to our end users. So I did mention there's a whole bunch of miscellaneous components. And this is just a small subset, but these are very common that you'll see in there. So things like Azure Function Apps, event grids, again, for doing more of an event-driven data warehouse. An example of that would be a file is dropped into my data lake. That file created event can then be used to trigger actions to go maybe consume that file. So it's now event-based, or there's any number of events, but that's just the file creation type event. And we would use something like Event Grid to kind of drive that logic. Speaking of logic, we have things like logic apps that are very useful for integrating into here. One of the ways that we use logic apps very often is actually handling our alerting and notification framework inside of things like Data Factory and inside of our workflows. We'll use logic apps to actually design that the workflow for those notifications when something goes wrong. We also have Azure Machine Learning, Azure IoT Hub, and then of course we have all of the business apps as well, such as Power Apps and Power Automate. They all integrate with this environment. So up to this point, with the one exception there of Databricks, we've only talked about Microsoft products. And if you remember back at the beginning, I said one of the goals of this kind of modern design is to avoid lockdown to a single vendor. And that is still true here. The point is this talk is specifically about a Microsoft's approach to a modern data warehouse. So that's what we're talking about. But I want you to understand that any of these components could be swapped out with something else. You don't want to use Data Factory? Fine, use something like Informatica. You don't want to use Databricks? Go ahead, use Cloudera. You need something to feed real time or to handle change data capture in your system from your other systems? Use Attunity. It ties in here just perfectly well. You don't like Azure Data Warehouse? Great, use Snowflake. All of these third-party components are interoperable inside of this environment. We can use them in much the same way that any of those other components are. And in most cases, they can essentially act as though they are kind of a first-party component. Microsoft's modern architecture inside of Azure is extremely open, and pretty much anyone can go and integrate with it and have a first-class experience by doing it. So you do have choices here. Now, I am biased because my job is to integrate Microsoft technology, so those are the things that I prefer, but I don't have a single client that is 100% sold on any of these vendors, and so it's always a hybrid, it's always a mix, and it works in this environment as well. So before we get into the demo, maybe this is a good point to ask if there's any questions about what we just covered, because I know I went through that pretty rapidly. All right, let me switch over to sharing my browser. All right. What we're looking at here now on the screen is an example of a Synapse workspace. This is the portal that I was mentioning earlier around Synapse. And this is kind of the default experience that you get when you log into a Synapse workspace. You have some of these helpful links around common tasks, some useful links, and so on. And this is kind of your home page for a Synapse workspace. So we'll walk through a little bit of the side menu. Let me pop it out over here. We have a couple main areas that we're going to talk about, but I'm actually going to start at the bottom. So in our bottom, we have our management section. This is where we actually connect to these various services. So this first one is my analytic pool. So our analytic pools, this is the compute that we talked about earlier. So I have two different types of SQL pools attached to this workspace. I have this on-demand pool. This is what I referred to earlier as that Project Starlight. So this is the serverless SQL query engine that allows me to query things in, let's say, data lake. And we'll look at an example. This one down here that's called Getting Started SQL. This is just a default sample instance, a standard SQL pool. So this is what used to be called Azure SQL Data Warehouse. You can kind of see its size here. I have some ability to manage this. I can come in and pause this instance, and I can, go to it inside of Azure and adjust configuration on it. So maybe I needed to scale it up or I need to scale it down and so forth. But in here would list all of the different SQL type computes that are attached to my workspace. Next, I have Spark pools. I don't have any Spark pools attached to this workspace, but this is where you would create them. So this is for any jobs that I have that might be running under a Spark system. Or if I'm doing maybe some machine learning inside of Spark, and I have some notebooks attached, this is where they would potentially run. This could also be where I would be running some of my ETL, some of my data flows from a data factory perspective, which we'll get into the development tab here in a moment too. Our linked services, this is where all of our various external services kind of come from a management perspective. So you can see that I have this SQL Data Warehouse here. That's one of them, but I also have a data lake associated with this. If I go over to a new linked service, and we're not going to add any here, but I just want to show that we have dozens of different services that are supported. So if you have a database, say I have a DB2 database, I can add that as a linked resource, and it now becomes a named resource within my environment, and I can now reference it with things like Data Factory to pull data from it and bring that data into this environment. Also connect things like a Power BI workspace. So I would actually see the reports and so forth from that workspace in this environment and be able to manage it mostly through here. Our triggers, you can kind of think of this as a little bit like our job agent from a SQL Server perspective. We would create new triggers here to kick off our various pipelines for data movement. They don't all have to be scheduled triggers. We can have an HTML, or sorry, an HTTP endpoint trigger where we have a service that can be called to trigger a job. We can have a number of things. That event grid type style I told you about, we can use in here. There's a handful of trigger types that allow us to kick off our pipelines. Integration runtimes. If you're already familiar with Data Factory, you know what these are, but this is essentially Data Factory's version of a data gateway. So if we need, Data Factory needs to reach into your local network to get access to a database as an example. It does that through an integration runtime. By default, you get this auto-resolve integration runtime. This is the cloud version of that integration runtime, and Azure will use this for any accessible data sources that it can get to. So let's say it's a web service that's publicly accessible. It will use this gateway to get to it, or this integration runtime. But you have a few other types of runtime. Again, the most common would be something that I would install on a local network that gives me access to my databases. Then we have some ability to handle access control, and we can set up some endpoints and so forth. Jumping up to the top, we'll go to data. Let this refresh for a second. So here I can view any database that I have attached. So we talked, I have an Azure SQL Data Warehouse attached to this, or a SQL pool. And it says getting started one, so I can see the tables inside of here, and I can create queries and so forth inside of this, or generate a new notebook to look at this. And again, if you're not familiar with notebooks, it's kind of a little more maybe on the machine learning side, data scientist side, or kind of the big data side, a way of interacting with some of these data sets. I also have the ability to kick off a data flow. So a data flow, again, is the flow side of integration services, the data flow side for Data Factory. In this case, if I do this, this would do it as a Spark job in the background. It's a visual interface where I can drag and drop and so forth, so I'm not writing any actual code for it, but ultimately where it's run and deployed is in a Spark instance. And I can create a new data set as well from this to access from something like Data Factory. But this is a little bit like having a management studio in my browser. So I can interact with the database instance from here. If I go over to my linked tab, this is where my storage account comes in. So right here, this is a data lake that I have assigned to this workspace. And if I open up my landing zone's just essentially a container for this. You'll see I have folders of data. So I have some sample data. If I go into it, I have some international sales, some US sales, and I just have files in here. In this case, it's, I think, a mixture. I have some Excel files and some CSV files, but you can have a wide variety of file types. But, you know, for having a fancy name, a data lake is really just a file system in the cloud. There really isn't much more to it. Under the hood, there's a lot more to it, but from our perspective as we're interacting with it, it's just a file system inside the cloud. So again, this is kind of our data pane. So I'm hoping as we're walking through this, you can kind of see how I am taking these typically disconnected services. So something like Data Lake and something like SQL Data Warehouse, or all of those other different connection types I showed you earlier, how we're starting to bring them under a single pane. So as a developer or as an administrator of this environment, I can start to see all of this stuff in one single place. That, again, to me, is where the power of something like Synapse Analytics comes into play. So if we go to our development tab, this is just essentially a repository for staged queries that we have. And so let's take a look at some of them. So this first one is using our SQL on-demand instance. And I am doing a query in my data lake. So Azure Blob Storage is what I'm doing. I'm connecting to that data lake. And I'm specifically connecting to this sales.csv file. This is a little bit of a different probably format that you're used to for SQL. And the reason for that is that whenever we're working with any of these kind of big data technologies, it tends to be a schema on read type of environment, meaning we can write the CSV in whatever format we want. But if I want to be able to read from that CSV, I now need to be able to define what the structure of that is. And that is what's occurring right here, as I am defining the columns that are part of this CSV. I'm also defining some of the format information. If I have a file type that actually has metadata embedded in it, let's say like a Parquet file, I don't need to do this extra hoops. The SQL on-demand engine will read directly from that metadata and understand things like the columns that are inside of that data structure. But for a CSV, it is just a text file, right? So I have to define this stuff. So if I run this, it's going out to the data lake, and it is initiating a query across that file, and it is returning back data. So the first thing to just notice here is this is meant to be somewhat of an exploratory service. This is not meant to be a blazingly fast service where you're going to get sub-second response time and those type of things. But it does allow me to query across files and all of that sort of thing with a very familiar SQL syntax. So again, I'm just doing a count of my records, and I have a little more than 4 million records in that particular file, and I can access it this way. So similarly, I'll open up another one. This is just an example of a standard SQL query. This is going against the data warehouse itself. And very simple, just doing a top 100 from my trip table that's inside there. And we'll run this as well, and it should return back that data. This will be a much speedier environment because now we actually have a relational database engine behind it. Again, it's still going to be dependent on how we've scaled that environment up and how we've structured maybe that data and so forth. But in general, this is going to be a much speedier environment than an on-demand environment. And so if you think about it from kind of a logical flow, we start landing data, and perhaps all of our data starts landing in that fluid data lake. We don't really care what it looks like yet. We use tools such as this on-demand SQL instance to query across it and do some discovery and find where the value is in that data. We then, which we'll look at here in a moment, use a pipeline inside of something like Data Factory to maybe move and clean up that data and then bring it into our data warehouse so that we have a query engine that is much more responsive and maybe can give us some more benefits as well. But there's a very defined kind of development flow that we would go through with this as data moves through our system. And so the idea, though, is we're not going to put all of our data in our more expensive resources, such as a data warehouse. We will leave the majority of our data in a cheap resource, such as our Azure Data Lake, until we've identified the value that that data has to our organization. Then we will go through the trouble of modeling the data, extracting that data out, and finally staging it up for our end users. So the last thing I'm going to look at here, just from a query perspective, is this uses the new copy into syntax for SQL Data Warehouse. And this is what allows us to actually connect to external resources. So this used to be referred to as Polybase inside of the data warehouse world, where we would use the Polybase functionality to mount an external table. What I wanted to show you specifically about this is I'm using this copy into, and I'm actually pulling this from a publicly available blob store. So this is a blob store that Microsoft maintains. So this is not part of my Synapse environment. This could be a vendor provided, a third party provided. This data can essentially live anywhere. In this case, it's a Parquet file. And I am going to take this data and I am going to load it into my data warehouse. Again, just simple syntax here. I'm just checking and see if this table works or exists first. If it doesn't exist, I'm going to create it with this copy into statement. So this might take a little bit to run, but it's going to copy a whole load of weather data from this, again, external third-party source into my Synapse environment, into my data warehouse, using just that kind of simple syntax. While that's running, though, we'll take a look at some other things here. So under my development tab, if I hit the little add here, this will give us an example of some of the things that we can define here from a development perspective. And much of this is the same as what we looked at when I clicked a little ellipse next to the various tables in our data tab. So I can create a new SQL script. I can attach that SQL script to instance of SQL Server, whether that is my on-demand SQL or whether it's a data warehouse like this. I also have that ability again to use notebooks. I can do data flows and I can do Spark jobs from in here. So all of those would be what are considered to be development assets in this portal. So this finished, took 41 seconds, and it loaded about 10 million records in. So again, just a pretty simple example of what it can do with doing kind of a cross system select in this case. We'll jump to our next tab. This is our orchestrate tab. I don't have any orchestrate examples in here, but we can show it off here. This orchestrate tab, this is effectively Data Factory. So if I come in anew, I have the ability to create a new Data Factory pipeline. It will load the Data Factory interface that you may already be familiar with. There are a handful of kind of new Synapse specific items that are listed here, but otherwise this is exactly what you would expect inside of your Data Factory environment. But instead of being inside of the Data Factory Designer, I am inside my Synapse workspace. And so I can do that from here. Simple tasks are also listed here for like this copy data. And all a copy data is going to do is it's going to launch a wizard for me where I can now go through and develop just a simple forklift type of procedure. So I need to take table A from system A and move it into, let's say, my data lake. Just forklift it. I'm not doing any transformations on the data. I'm just picking it up and moving it. That's what this kind of copy data activity would do. That sort of task is handled completely inside a Data Factory. If I actually want to do more of a transformation, that is when I would come in here and I would do something with an actual data flow and have that kick out to some sort of third party. This is again where that kind of concept of compute comes into. I need a compute element to do something against my data. I can define that myself. So let's say I wanted to use an Azure function app to do it. I can do that. Or I want to use a machine learning algorithm to do that. I can do that too. Or I can use some of the built-in things inside of Data Factory, like the visual data flow engine, and use Spark under the hood to do it. And last, I don't have much to show here because this is not a real environment and I don't have pipelines running and triggers going off, but we do have a monitoring aspect of this as well, where any of your pipeline runs and stuff will show up in here and be able to be viewed from a success fail type of scenario. You can rerun them, you can view the errors. So it's a centralized place again to see the results of what is going on in your system. This is very similar to what you'd have inside a Data Factory from a monitoring perspective, but it has some additional stuff. So again, we can see the actual requests to our SQL servers, for instance, in here. And so we can view what is going on in those environments. And that's not something we can do in Data Factory by itself since it's a kind of a disconnected service. So again, Synapse workspaces pull all of this together in a single place. All right, we're gonna head back to the slides. All right, so all of that leads to this kind of a visual. So again, think back to that original diagram I showed kind of around the traditional data warehouse. Well, this is the architecture primarily around our modern data warehouse. The important aspect again is to understand that these pieces are modular. When I launched this initially, I might not have a need for Azure Machine Learning as an example. So great, I don't bring it along for the ride. That component is completely optional based on my needs. Maybe I don't have a need for Azure Analysis Services. Or maybe alternatively, I have a need for those things, but only a short period of time. Maybe I have a project that I need to use machine learning for, but that project is a little bit transient. It's going to last me 3 months and then I tear it down and throw it away. That is where this kind of modular aspect comes in, where we can grow. All of these components too are things that I can expand on demand, and I can programmatically do that as well. So take something like Azure Analysis Services. It has scale up and scale out capabilities built into the service. I can build routines that look at the load that is currently occurring in my environment, and I can have it adjust accordingly. So I can have it start to do a scale out. So now maybe instead of one instance, I go up to 7 instances or something along those lines. I can manually do that as well, but I can programmatically do it so that the systems are reactive. Same thing with like Azure Synapse, the data warehouse components, same thing with Databricks, the same thing with almost all of these components. Some components such as Data Lake are fully managed. That sort of scale lane is done in the back end. I don't provision Data Lake and say that I need X amount of storage. I just provision a Data Lake and it'll grow as I continue to add things to it. So if I'm using 100 gigs of data today, great. And tomorrow I need to load in 50 terabytes. Well, I can do that. It'll take some time, but I can do that. And so this model is a lot more flexible than what you would typically see in that traditional model. Would point out that this model is not necessarily for everyone either. There is an overhead associated with trying to manage an environment like this. So if you don't have needs where you need some of this flexibility and so forth, this might not be the environment for you. If all you're going to do is spin up a data warehouse and let it sit at whatever DWU size that you set it at, and you never touch it again, well, you're not really, getting full advantage of this kind of elastic modern workspace. And not necessarily anything wrong with that, but you're not necessarily getting any real advantages over kind of that traditional workload. But this is where the end of the road is with this. It leads to something similar to this. And again, keep in mind that any of these components could be swapped out with non-Microsoft components if that's what you would choose. So let's move in a little bit talking about Lifecycle. So this diagram is straight out of the Ralph Kimball Data Warehouse Lifecycle Toolkit. This is the quintessential model of lifecycle management for development in the traditional data warehouse world. And this is 1000% designed to support these big waterfall style projects. It is very difficult to be agile in this sort of model, and it wasn't, quite frankly, ever designed to do it. Now, there are a handful of methodologies that have been adopted over the years to make a traditional data warehouse more agile, but it still follows this sort of pattern. It just tends to be, it's mini waterfalls instead of one monolithic waterfall. So again, we're not going to necessarily go through the individual aspects of this from a life cycle perspective, but just understand that a lot of this is, again, monolithic in nature. It tends to be, and it tends to be these large waterfall style development approaches. In a modern data warehouse, we tend to have a very different life cycle. I alluded to this a little bit as we were walking through some of this, but essentially I start with the ingestion of that data. I don't care where it's coming from. I don't even care so much that it has a lot of value, because my storage medium with something like Data Lake is very cheap compared to most on-prem storage, at least enterprise on-prem storage. Somewhere around the retail price is somewhere in the neighborhood of like $20 a terabyte a month or something like that. So I can store vast amounts of data there without having to worry about vast amounts of costs associated with it. And so the typical life cycle is I grab it in case I need it. I'll worry about cleaning it up later. I'll worry about whether it has value later. Then I start getting into that point. Well, how do I discover that it does have value? So this is where you use some of those on-demand tools to query over it to start answering basic questions. This might be if your organization has data scientists, where you would let them go to start exploring and finding what those paths look like to getting answers. Once that is done, and I have identified some area where I need to be able to answer a specific question for my business, or a specific area where I need to gain insight, I then move into this kind of next step of curating it. This is where I clean it up. This might be where I train a machine learning model if I am going down more of that data science perspective. But this is, again, where I start taking it and formalizing that process. It's no longer just about dumping some random data into my data lake. It's now about curating that data and building some level of data governance around it. And that leads directly into the next step, is when I start modeling out the data and integrating it. This integrating, though, is interesting because the modern data warehouse is meant to have integration points all over the place. So it's not just about integrating this from my source system and into my data warehouse, but it's also about integrating aspects of my data warehouse with my operational systems. I want to be able to turn these insights that I'm learning about my data into something that is actionable. So probably an easy example of that would be in a healthcare scenario. Maybe you want to be able to look at patient data that's coming in, have that go through a machine learning process, and then alert a downstream operational system based on the history you have around this patient that they're at risk for some category. It doesn't really matter, again, what it is. But we want to not just lock that data into our data warehouse or lock it into our reports and dashboards. We want to be able to utilize that to trigger downstream actions. So again, maybe it triggers something that sets off an alert in an operational system. So when that patient calls in, the nurse who takes the call or whatever it is already presented with this information around what they should be gathering from that individual patient. Again, there's lots of examples of where that could be done. But I just encourage you not to think of integration in the same light as what we do in that kind of traditional world, where it's just about taking it from that source system and integrating it into our pipeline to get it into our data warehouse. Because the data warehouse is ultimately not the ends for us. That's really kind of just the beginning for us. That is where we want to start extracting that insight, but us being able to turn that into something actionable is the ultimate goal. Finally, we then take these insights that we have, we visualize them, we push it down directly to the customer or the consumer of this, our end user, so they can explore and ask their questions of this data. They inevitably are going to have new questions, and there's inevitably going to be new data, and the cycle kind of starts all over again. Long-winded way of basically saying that this is a very cycle-oriented life cycle. Again, right in the name, but it is much more suited for this kind of an agile approach than what you would typically see in a traditional data warehouse world. Now, I don't know how much this resonates with you guys that are here on the meeting, because I know a lot of you are probably coming from more of the SQL Server, maybe administration or development side of the world, and not necessarily as much from the analytics side of the SQL Server world. But this is a pretty monumental change to how we've been doing things for the last 30 years. It really changes our ability to respond with these things much, much quicker. It's probably much closer to what you would see in a modern development environment than what we've ever had in the analytics world before. All right, so let's get to the fun part. What questions do you guys have? Feel free to either funnel them in via chat, or you can unmute yourself and ask as well.
I haven't seen anything coming in via chat yet, Pierre, but I guess one of the only things I'm just dealing with is, trying to, some of the people are saying, they hear a lot of the buzzwords of, hey, I want to go to the data lake, currently an on-prem data warehouse. I'm currently, running it the old style methodology that you were showing, and we just want to migrate, let's just do it. And what have you seen as like, what's the process that you found easy to kind of like actually do that?
Well, I don't know that I would actually recommend that for a client as a path, unless they actually have some of those drivers that we mentioned earlier. Just moving for moving's sake doesn't, other than maybe being cool, doesn't really add much value.
the reason they want to do it, it was the main reason they explained it to me was being able to, spin up and spin down resources.
Yep.
They only really need the compute when they're running the loads. They don't need the compute when they're not, and they want to be able to spin down and save cost. So
Yeah, the cost is easily the number one reason we hear for a lot of these things, and um, it's probably one of the worst reasons in my opinion. And the reason why is it is really, really easy for some of these systems to run away quickly if you don't have some of the governance and stuff in place, where this is no longer going to be a cheaper option. It becomes a very, very much a more expensive option. You are, tightly confined as to what your runaway costs are on-prem. You're not so much on the cloud side. You can go from spending, a couple $1,000s a month to spending hundreds of thousands of dollars a day
right.
very, very quickly. So again, but I'm not ignoring what you're saying. So what you would do though, if you are looking to kind of use this as a way of getting to that more of an elastic side where I can, adjust resources based on load, is your first step is probably to just migrate your data warehouse over to something like Synapse. So it's essentially a forklift where you pick up those tables, I migrate them over. It is still a SQL server at its heart. There are some very key differences, especially when it comes around tuning this environment, but it is still a SQL server at heart. So if you have a relational style database on-premise doing this today, chances are you can rather, don't want to say easily, but it's fairly straightforward what that process looks to do it. Then you might want to start backing into replacing some of your ETL pipelines with some of this more modern stuff, either around Data Factory or using Data Lake as an intermediary. I don't think I would necessarily start, though, by recommending that you rewrite your ETL processes and have them all go through that intermediary layer of a data lake and so forth. Because again, on its own, that has very little value. And so it fails that ROI test that we kind of talked about early on. But forklifting your existing data warehouse over to something like Synapse Analytics and a SQL pool, there's some immediate things that you can gain from that. One is that elastic nature where I can adjust it up and down, but it also has the ability for me to maybe integrate that into a wider number of services that's a little bit harder for me to do on an on-prem environment. So that's where I would start.
I got it. Appreciate it. Thank you.
Other questions?
Yeah, I got one. This is Anthony Thomas. How you doing?
Pretty good.
I appreciate you hosting this today. Actually, I have two questions, but tying into the last one, how does this modern architecture help or interfere or compound issues with, basically data or data process sprawl, right? And upstream and downstream dependencies, right? We're trying to decouple everything, but if you're just grabbing sources and targets and then you reuse, then you end up with spaghetti all over again.
Yeah, and it definitely opens the door to compound that issue. It really needs to be strongly coupled with some level of data governance around this environment. I mean, just take a single component of it. Take Power BI as an example of this. With Power BI being first and foremost a self-service tool for your end users, the gates are swung wide open for them to create dozens of workspaces and hundreds of reports and dashboards and have them spread all over and have thousands of data sets associated with them, and you're back in your spread mart hell that we've all been trying to get rid of for the last 30 plus years. And so it's very, very easy to get back into that space. So how do you manage it? Well, I don't know that there is an easy answer other than be aware that this is a problem, and there are some defined steps to kind of take around it, but it's going to take work and it's going to take some commitment to go through it. There are some tools that are provided to you. So again, looking at the Power BI side, there's a whole bunch of administrative reporting that's either out of the box or that you are capable of doing using things like Microsoft's Graph API to pull this information and then get an understanding of what your users are actually doing. You have
Yeah, so you
similar
do
things.
more audit kind of stuff. Yeah.
Yes, it tends to be much more on the um, checking up on your users and their activities, that audit methodology, than it is being able to prohibit and put, you know, rails on what they're doing. It's much
Right.
harder to kind of fence them in some of these environments than it is otherwise. That said, I mean,
Yeah.
everything we talked about today has, you know, pretty granular security. I mean, we can go down to object level security inside of something like your data lake that prevent people from just writing anything and all of that sort of thing. And you may never ever give your end users direct access to that data lake. It might only be more of a IT or a data scientist type of a playground, but that doesn't stop your IT components from going crazy with it either, and so on. So
Right. Right.
what I would say though is something we did not talk about today, and we didn't talk about it today on purpose because it's not quite here yet. That would be the next generation of Azure's data catalog. So Microsoft has been working for I don't know, at least 2 years now on rewriting what was originally data catalog and are kind of reinventing it. And it was originally set to kind of go into preview of January of this year, but that kind of got upset with um, a purchase that they made. They bought a company that specifically has a set of technologies around integrating kind of a rules engine into your data governance. It was in response to some of the regulation coming out of Europe. And so they've spent the last 6 months plus kind of writing that into Data Factory. And keeping my fingers crossed, I hear that they are close to doing a public preview with that soon. It is in private preview right now. It's I think it's called Project Babylon. And I think they're still accepting people into the private preview if you guys actually have a need for something like that. But it, one, ties in that kind of metadata layer where I can get an understanding of everything that's in my data estate, no matter where it lives, whether it's in my data lake or in the servers and so forth. Plus, it allows me to add some actual rules on top of it for data governance. And this is where I can start fencing this stuff off or putting in rails for it. But it's outside of private preview. It's not quite here yet.
Perfect. That was, yeah, probably a big question. I kind of knew it was going into it, so I appreciate the response on it. The second one should be easier. Talking about the scale out and scale in.
Yep.
Now, regardless if you do it manually, if you do it through some automated, or is there some type of control, or is it automated as far as redistribution of query or workload, or do you have to put things in to actually utilize that scale out?
It depends on the resource. So if we talked about, again, what used to be called SQL Data Warehouse, there are resource classes that you can assign to users and kind of groups inside of your SQL server. And if you're in some of the lower resource classes, it doesn't particularly matter that you scaled up the instance. You're not going to be able to take full advantage of that. But if you're in one of the higher resource classes, you can easily bring the whole thing to its knees, as an example. Now, that is primarily managed through some just standard SQL statements, some alter statements and so forth. So you can alter that on the fly at the same time that you do some of those growths.
So they're
but
akin to it's akin to the federated kind of distributed systems and queries where you join them all back in together, that kind of thing.
Yes, and then like on the other side, something like Databricks, as an administrator, you kind of just set up the bounds. So you say, I want a cluster that's anywhere from 2 to 64 instances, as an example. And it will auto scale based on the load. And based on the load, it will take up every last bit of that if it thinks it needs it. And then when it's been idle for a little bit, it'll start taking it away. It's all
Gotcha.
automatic. Now you can, again, set some of the parameters. How quickly does it start taking it away? How quickly does it start scaling up? And you, again, put the upper and lower limits on some of those things in the configuration. So you have that ability to do it. And it does largely manage it for you, but it depends on the system. It's similar type of things with something like Data Factory. Data Factory
Right.
tends to be a little greedier. It will usually, you know, if you set an upper limit, it's going to try to hit that every single time because it's trying to get in and out as quickly as possible. I know I had a recent project with an insurance company where we were pulling data out of AWS into Azure, and we were pulling somewhere in the neighborhood of, I don't know, a few, like 12 terabytes of data. And we were able to spin up enough instances to do that in about 3 minutes. But that is hundreds and hundreds of instances doing it. And it'll do it if you want it to. But of course, that gets pricey too. But it's a balance. Longer it runs, the more expensive it is. The more
Right.
instances, the more expensive it is. So you kind of try to find that sweet spot to get
Well,
in.
and managing more smaller instances sometimes is more economical than using one or two big honking ones, right?
Absolutely.
Because the cost isn't linear with size.
Yes, absolutely. It's,
Okay.
I mean, if anything you guys get from kind of this conversation is, if you're going down this road, you need to be extra diligent about understanding how cost is accrued in these sort of consumption models. Because like I said, it is very easy to consume data quickly. I had a small client that was just doing a tiny bit of data factory work inside of their environment, equating like maybe $12 to $15 worth of data factory time. And they messed up a little bit, changed some parameters, and they went from that to eating up about $15,000 of data factory time in a matter of a couple hours. And so you do need to be very aware of how it works and how to put some limits on it, just as a warning.
Oh yeah, forgot and join and forgot to got run away or something on you. Now instead of a million rows, it's 10 trillion rows. Yep.
Precisely, it's that sort of thing. And so that burden, though, of monitoring that and looking for those cases, that is on you. Microsoft gives you a lot of tools to be able to do that, to find the stuff, but out of the box, there's no like limitations on any of those things. So if that's something you care about, you're going to want to utilize those tools to actually put some of those things in place. At the very least, alert you that you have a long running process here that's eating up money as it's going, type of thing. But I just, again, bring it up because it's something that especially new people to these type of environments are not necessarily aware of, and they'll look at something and say, oh, this is only going to cost me $2 to run this or whatever, and then that's great until it doesn't. Any other questions?
Hey, Pierre, this is Brian Stanley. Can you hear me okay?
I can.
Okay, I have a general question. What kind of general, are there any Slack channels or anything that you follow personally to kind of keep up on data lake technologies and any kind of trends that that help you out?
Not necessarily specifically, and it's actually probably gotten a little bit worse. So Microsoft used to have a pretty good Azure advisors Yammer community, and they kind of tore that all down a few months ago and kind of repurposed it, and so it isn't necessarily as transparent. So for instance, with data lake specifically, if it was a technology set that you were interested in, every other week the data lake product team was doing a customer facing kind of lunch and learn type thing where you could go and ask questions and they would do a demo of what was coming and stuff, and all of that stuff has disappeared. So it's gotten a little bit more difficult to keep up with it. At the same time, though, you're starting to see, as this technology becomes a little more prevalent, it's starting to pop up on people's blogs and so forth. So there are a few places, but I don't really have a single place for you to go look. There is still a customer Yammer group for Microsoft that is pretty good with that. It's just it's not as team and product focused as it used to be, and it's primarily focused on doing feedback from the customer side and not necessarily on just the kind of helping the customers understand the ecosystem as much. But that's also, I guess, where some of these type of user groups definitely become more important. And as I mentioned earlier, if there's any deep dives on any of these type of topics that you guys might be interested, I'm more than happy to come back in the future. Like if you wanted a more of a deep dive around data lake as an example, just kind of going into the technology and going into some of the examples, and I'm happy to do that.
Okay, I think I'm familiar with that Yammer channel. We had some discussions about Azure Data Catalog, as you and Anthony were discussing earlier,
Yeah,
mostly around requests, So
and
okay,
that is again an area where they've been pretty silent. I mean, if you go out there and search, I don't even know if you can find any mention of a Gen 2, but they are working on a Gen 2. Again, the details of what's there is all under NDA and so forth from their private preview, but it's coming at some point. And
yeah, I'm buttoning my lips right now. I want to say stuff, but it's NDA, so it's. Yep, I know it's coming. Yep.
and hopefully
Thank
sooner
you.
rather than later. Any other questions?
I think at this point, Pierre, what we'll go ahead and do is, if there are any questions, we have your contact information. I believe that's in the email. If it's not, I will make sure it's there. Or email again, kansascity@pass.org, and I can pass those questions along. Happy to be able to do that. So, all right, Brad. Brad says thanks, Pierre. So,
Well, thank you guys. Thanks for having me.
Yep. That's about, let me go ahead.